Coming from an architecture background, I'm interested in the real world. I'm interested in real materials, in light, in form, in finishes, in things that you can experience outside the screen. And robotics is that bridge. It's the bridge between the digital world and the physical world.
We've got something really unique for you today. We're not profiling a company or a product. There will be robots, there won't be any AI, there might be giant freaking lasers, but we are here at a small municipal airport in Northern California to profile an artist. His name is Charles Aweida, and he designs systems that integrate nature and robotics, the digital world and the physical world, and I can pretty much guarantee you've never seen anything like it. Hey.
Hey.
Good to see you.
You too. Welcome.
Thank you. Excited to see what you got cooking.
Yeah, come on in.
All right. Okay, so you make art in a way I've never seen anybody else make it. Can you tell me a little bit about the process?
What I do is I take machines that are traditionally used for automation and I repurpose them to create fine art. This is my latest piece, and it's comprised of 1,012 uniquely bent pieces of wire.
It's really mesmerizing, the precision at which you can see the thing kind of evolve as it comes this way.
Bloom is based on abstracted flora, specifically the architecture of petals. What's really fascinating about flowers is it's one of the most ordered, rule-based pattern systems that I've seen in nature. So the idea behind Bloom is to have a series of bulbs that are closed on one end and open on the other end. This was the first piece using my new three-dimensional wire bender.
What would this wire bender normally be doing if you hadn't rescued it into the world of art?
So this machine would have an incredibly depressing life of creating shopping carts, but it's been rescued to live out its creative dreams. There's quite a bit of complexity here with over 1,000 shapes that are all unique. And so I've developed an entire system to produce all the shapes, but also manage and organize them so I can work with these robots and hand assemble the artwork. I often describe myself really as a systems artist. Robotics are one part of the system, software is another part of the system, and the data or inspiration from the natural world is really the parameters that drive these systems. By bringing these systems into the computer, you can manipulate them, you can abstract them, you start to see new things emerge. And so this is where robotics becomes really pivotal in this work. You can bring it back out into the real world. I created my first piece of art in grad school, and it was an array of nails that were placed in different angles that was based off of wind data. And that was sort of the intro of me working with robotics. And I had full control of this robot. It was one of the best feelings I've ever had to just collaborate with this machine.
One piece you did was animated dominoes, right?
What I was looking to do was create the first fully robotic driven stop motion animations. So for example, like a guitar string strumming that has this elasticity that snaps back and forth, that's done with a physics simulation, and then the robots bring that animation into the real world with a physical object, and then there's a camera that's following this, and it's all one system. So this is 350 pounds of aluminum, 1/8 of an inch thick.
So comes off a spool around here and leads into, what does this box do?
So this is a wire straightener. The wire is fed through this tube and it feeds to the end. The bender will bend the shape, and then the robot will come into its unique position, which is different for every shape. And then the robot will send a signal and say, okay, I'm ready for you to cut the wire. The bender will slice that wire, and the robot now knows it can move this piece out. Each wire is then placed on this table in a very specific order in a grid. That allows me to not lose my mind keeping track of thousands of pieces of wire. These two robots are communicating the entire time. So this is Grasshopper 3D, where the entire system is designed and orchestrated. And so This is just an incredible tool for me to manage the complexity with having multiple robots, software inputs, software outputs, different programming language, all kind of in one place. I can also write custom software, getting the shapes in a format for the wire bender to understand.
I see like bloom part 940, bloom part 941. So each line is its own piece of that.
So each one of these numbers corresponds to one of the pieces of wire. Everything in this entire system, from the pattern to the wire bender to the robot placing it, is all parameterized with this tool. And so that really just helps provide a lot of power to create. So now I kind of have the entire system that's working really well together, and it's taken a couple years to build. To produce one piece of art about this size now takes me about a week, from bending to placing to welding, and then finally to finishing the piece.
And today's the day you're finishing this piece, right?
Yep, we're on the last row here, and these are already bent and laid out. It can then move into placing each piece of wire in its pre-drilled slot. And I'm on the last one, and so we'll give you the honors.
You sure?
Yeah, I'm positive.
Oh my
So
God.
you can place that last one.
Let's see. All right.
That's it.
Congratulations.
Thank you.
It's a beautiful piece.
And we're all set. So now we'll flip this up and weld it. It may sound like a surprise, but I try not to get too wrapped up in the tools. I'm still hand placing each pedal. I'm hand welding each piece, and I'm actually introducing more made by hand processes. I am a deeply technical person, and I do love robotics, but at the end of the day, they're here to serve the creation of the work. This piece is made out of raw aluminum, so it has this kind of silver tone to it, and we're gonna powder coat it. This is gonna be pretty cool because this is a color shifting powder coat. So it has a gray base to it, but it has a purple flake. I'm really trying to add another layer of depth to my work with color, and so this is fairly new for me. So it's gonna be really exciting to see how this comes out.
Is there a part of you that's got like some anxiety? Like it could go in there, get this coat on it, and it comes out, and you don't like it anymore?
You don't fully know what you're gonna get.
Right,
You know,
right.
You have an idea, but I think that is the excitement.
Right.
That maybe it could go wrong.
Oh, wow.
Good.
Yeah.
Those tones that you see in the natural world where like there are these subtle shifts, just give it that organic feel.
Yep.
And then it's kind of cool too, the powder coating gives a little bit of like softness on the edges. Next we'll get it on a wall, get it in some natural light.
That's my piece right there. What does it feel like to see it on the wall after all the planning and designing and making?
The biggest feeling is really a sense of relief. More so than euphoria. Just like glad everything worked. There's so many moving parts. I think the euphoria comes from the new ideas.
So where do you go from here?
Big robots and lasers. The next frontier for me is audiovisual experiences. So I'm playing around with large-scale industrial robots, holding very powerful RGB lasers. This is a couple days of experimentation.
Yes, this is just the very beginning.
Very beginning. Right now, I'm in a very exploratory kind of phase with it. It's been about some of the technical challenges and getting everything working, but still exploring some of the same concepts of form, of the natural world. I don't entirely know what's going to come with it in the future, but I love this idea of creating a sandbox to play in. It's a really exciting time to be creating. We have all this opportunity with technology, but for now, I'm just approaching it with curiosity. I'm looking to explore and see what happens.